For a vector field in the plane, so m equals x, y, I, plus n of x, y, j, we defined the k component of curl by curl f dot k. This was del n by del x minus del m by del y. And this measured the rotation which is caused by the vector field f. So we had this paddle wheel interpretation. Now, as the name suggests, this is only a shadow of a more general concept of curl, which can be defined for vector fields in 3 dimensions. So that's what we'll study in this section. So definition, let f now of m x y z I plus n x y z j, and also there'll be a k component p of x y z k, be a vector field in R3, and again we'll assume that these functions are reasonable. So m, n, and p should be continuously differentiable. Then we define the curl of f. So this will be a new vector field. This is the vector field. We'll either denote it by curl f, written out like this, or nabla cross f, which is a helpful mnemonic. So using, again, this slight abuse of notation where nabla is the vector del by del x, del by del y, del by del z. And we put m and p here. So this will be, so we take del by del y of p, so del p by del y minus del n by del z I, plus then for j we've got del m by del z minus del p by del x j, plus, and then for k we have del n by del x minus del m by del y k. So if we had a vector that was in the plane, then p would be 0, and also del n by del z and del m by del z would be 0. So for vector fields in the plane, we recover our previous definition of curl, or the k component of curl, but this is more general. And notice that, so sort of z and p are both kind of associated with k, and so we don't have either p or z appearing in the expression for the coefficient of k. Similarly, we don't have an x or an m in the expression for I, the coefficient of I, and there's no n or del by del y in the coefficient of j. So this is sort of measuring how the other directions are like twisting into this or around this axis. So once again, there's a rotational interpretation. So interpretation, if f is the velocity field of a fluid, then a paddle wheel placed in the fluid at a point, let's call it Q, x0, y0, z0. This will rotate so first this will rotate around an axis which is parallel to the curl vector. Again, this is a new vector field, so we evaluate that vector field at Q, or at x0, y0, z0. So this tells us that the rotation is happening, say, around like an axis like this, but it doesn't yet tell us if the rotation is going clockwise or counterclockwise, or if it's going clockwise. So second, this so this will rotate counterclockwise when viewed from above. Or in other words, with curl F at Q pointing towards you. So if we just said parallel to this, then that doesn't distinguish curl F from negative curl F, but now this does. So if this is pointing this way, then so if the vector is pointing this way, then the rotation will be counterclockwise like this. And finally, so far, this tells us, this is what the direction of the curl vector is telling us. Then the angular velocity, so how fast is this rotating, of 1/2, so not, magnitude isn't quite the angular velocity, it's twice the angular velocity. So we'll, again, justify this interpretation in a later video, but I just wanted to state it now. So let's do an example. So here we've got the vector field F equals x, y, I minus x, z, j plus y squared k. And I've illustrated that, and I've also illustrated, sort of put a paddle wheel in. You can move that around, and it'll rotate in the sort of physical way that it would actually rotate. Okay, so let's calculate the curl of this. So curl of F is I j k del by del x, del by del y, del by del z, and then xy negative xz y squared. So this is, so for I, we take del by del y of y squared, which is 2y, and then minus del by del z of minus xz, so that's plus x I. For j, we'll be looking at del by del z of xy, which is 0, minus del by del x of y squared, which is also 0. So there's no j component. And in when you adjust the sliders, you'll see that the arrow only moves in the xz plane. And then, so for the k component, we look at del by del x of negative xz, so that's minus z, minus del by del y of xy, so that's minus x. Okay, or we might rewrite this as minus x plus z of k.